My name is Elsa Bernard-Moulin from IC'Alps, a member of the ARM-approved Design Partner Program, which is a global network of design service companies endorsed by ARM. Our mission as an ARM partner is to help you bring your innovation to life with our custom SoC design and supply expertise and the ARM IP technology. Thanks for joining me on this tech talk, in which I will specifically focus on defining the SoC and the appropriate business model to secure your ROI and achieve success. If you are watching this video, it's certainly that you have a problem with the integration of your electronics. You cannot achieve the performance you need with your design. The performance is too high, as are the costs. There are no off-the-shelf components that offer you a good solution. Sounds like it's time to go for a custom SoC approach. A custom SoC is an integrated circuit tailored to your needs and exclusively delivered to your company. The benefits of using custom SoCs rather than off-the-shelf standard products or FPGAs have been recognized by the semiconductor ecosystem. This approach enables miniaturization of your system and cost reduction. The first-to-market strategy is key for a startup company. That's why, to achieve faster time to market and ensure that your company gets the competitive edge over others, you may, for example, develop, prototype your ARM-based hardware and associated software and ship your first product with an FPGA. Then, when you have reached significant volume, you can replace the FPGA with an SoC to capitalize on the lower unit cost, the smaller size, and the lower power consumption it brings to the table. Another advantage of custom SoC is that it can boost the performance of your system, be it power efficiency, analog front-end resolution, or computing filtering capabilities. Let's take edge computing as an example. Today, in today's intelligent, interconnected devices across industries, from smart city and VR to IoT and gaming applications, are driving the need for AI and edge computing. This is the concept of taking action on data as near to the source as possible. Let's say a sensor, to reduce the latency and bandwidth consumption, as well as secure computing and storage. And clearly, ARM-based custom SoC have proven their superiority in filtering, aggregating the raw data, and running analytics on site. The third major advantage of custom SoC is IP protection. Because yes, reverse engineering is always easier if your electronic subsystem is a collection of off-the-shelf components. No matter why you choose to build a custom SoC, one of the most critical steps to secure your ROI will be the definition of the SoC architecture, SoC architecture. So based on your target IC specification, or if you don't have it ready, based on inputs such as system description, interfaces, integration constraints, operating modes, the IC architects will work with your company to define the optimum SoC architecture for your application. Then it's time to partition the entire SoC's functionality into multiple functional blocks. A custom system on chip is generally based around a CPU or multiple CPU-GPU subsystems, embedded memories, communication interfaces, and some analog blocks for functions such as sensor interfaces. Architects like to brainstorm many possible options for the SoC architecture and discuss their pros and cons while considering performance implications, technical feasibility, design cost, and cycle time. During this phase, architects also define the relationship between the different functional blocks and allocate time budget to each block. Once architects have high-level idea of the functional blocks they needed, they identify the critical modules and define whether they need to reuse IPs from previous projects, make changes to existing IPs, or procure them from third parties. ARM-approved design partner members such as IC'Alps have a privileged access to a wide range of IP in the field of ARM-based processor cores, but also I/O and interface IP. A good architecture focuses on gleaning the best performance of the chip while minimizing the hardware resources, which directly helps in keeping the overall cost of the chip within the allocated budget. For example, for an IoT device requiring medium computing performance, analog subsystems, a mature silicon process such as 0.18 might be a good option as long as unit cost is not critical for success. As an independent design house, you can count on IC'Alps to select the optimum SoC architecture and silicon technology for your needs, and to capture all these technical details in an architecture document. Some ARM partners, such as IC'Alps, can act as a one-stop-shop solution provider, taking full responsibility for the design, industrialization, and silicon manufacturing of your SoC. Within the company, we have an extensive database of PPA data for ARM-based design to be in the best position to support customers with the selection of technology and foundation IP for your SoC. And the fact to include the supply chain management in a range of services gives us the reactivity and the independence to design a personalized supply chain, only considering our customer needs. And the turnkey model is the most appropriate business model to secure your ROI and achieve success if custom integrated circuit is not your core expertise. And if your company just needs to leverage a design service company in your SoC design, we can come in too. We have expertise in IP integration, design verification, and physical design implementation, especially in areas such as custom analog and multi-core processor subsystems that integrate several ARM cores on a single line. What we've just discussed about defining the SoC architecture is the first step of your SoC journey. Today, I will not go into the various elements that are detailed on this slide, but rather focus on outputs of each step. The best path forward time to market acceleration and risk mitigation is by starting a custom SoC design from an architecture specification, combining in-house analog and digital IP components, redeploy or redesign from scratch, and some third-party IP components. After the design phase, your SoC will be ready for silicon. This is a very good news. And prototyping is the next critical part to be sure that the SoC developed is exactly what is required in the full system architecture in performance, size, and cost. And then the industrialization starts when your design and supply partner helps you turn your first SoC prototype into a robust manufacturable circuit, introducing industrial test and packaging strategy. Of course, regular customer review meetings are held through a project. So if I made you panic about the development time required for a custom SoC, then it's time to reassure you and to get this information on the table. From spec to prototypes, it takes 10 to 16 months. Your spec to product journey will typically last between 1.5 years up to 2 years. And the added value and benefits offered by custom SoC design must, of course, be set against the development costs, including NRE charges required by the design partner for items such as chip implementation, IP access fees, and mask charges, among others. If you have to secure the ROI of your custom chip project and have limited funding, the fast, low-risk path to custom SoC is to start with a pre-study. A pre-study only represents 2 to 5% of the overall cost of a concept to silicon project, but it provides you with all the technical elements required to evaluate the viability of your SoC design supply project, including the definition of the SoC architecture, which is critical. The pre-study also provides a fixed price quotation for both NRE and the unit price, along with project timescale and risk assessments. So if you would like any further information or have an application that you would like to discuss with us, we are here for you. Thanks a lot.